In TNO Unboxed, we tackle new technologies in the security domain. We do this together with the experts from TNO. Today's experts are Marta and Oscar, and they know everything about vapor detection technology. This technology works anywhere, in any location, at all times.
That's certainly not true. The most important is how sensitive is the technology and how good is your sampling.
Today we're going to unbox vapor detection technology. This is TNO Unboxed. A TNO Unboxed box.
Wow.
Drawers and icons and...
It has a kill switch as well.
It's safe.
That's good.
How good is your sense of smell? Scent detection can play a crucial role in police investigations and the security research domain. So the small box with the anise scent contains the right clue to start unboxing. The small box with the anise scent.
It's not this one.
It's not this one either. This is really strong.
Yeah, this is very... I know the smell.
This is... This smells like licorice. Typical Dutch.
So how does it work? How do we smell?
We smell different molecules that form a fragrance. It can be more and less depending on how volatile molecules are that form the odor.
And this is what your research is about, what you are doing?
Our research goes not only about something we can smell, but about very small concentration of molecules that are released into the air. The concentration that absolutely cannot be seen, but are crucial and can be analyzed with the instruments.
Yeah, which one was it?
This is the anise.
Yeah?
Yeah.
Even the card smells a lot like anise. Remove the round lid at the top of the TNO box. And take out any objects you find in the TNO box. Exactly. A little bag. We got some pictures, we got some... It's for later. Like little device, glass tubes. It sticks to the table.
It's magnetic.
Ah, it's magnetic. And an iPad. TNO Unboxed.
Ah, yes. What you see here, that everything that you do, there's vapors emitted. When the person squeezes the package, you see some vapor coming out of it. So it will be transferred through the room. Even from packaged boxes, vapor will emit. Here we can see it, but normally in the real world, you normally do not see any vapors emanating from an object. This is made visible with special optical techniques. And of course, this is a lot of vapor from shooting a gun. But you see how far the vapors go, and they will contaminate the complete room where this shot is fired. And when people work with this kind of materials, they often do not even realize how much they contaminate the room and the air that they're in here. And all those vapors can be detected.
And I guess these are the materials you use in detecting them. What is this?
To detect the vapors, we need to analyze it. Before analyzing, we need to sample the vapor. And those are examples of different filters that we normally use in everyday laboratory work. So, for example, you have here a glass tube filled in with certain polymer that is very porous, that can absorb other molecules. You attach the filter media to the pump, suck the air through, and let the air go through the medium. Or we could also use, this is a very small stick, so you could hang this in the air and let the molecules absorb. So this is a certain coating here, and you have also different sizes and different thickness of the coating, depending on what you are looking for. So then you know
it's important indeed to know what you're looking for.
And then you need to analyze it. One of the typical instruments we are working with is gas chromatograph mass spectrometer. So actually we can analyze all the fragrances, all the molecules that we trap on our filters and identify them.
And this is the mass of all the different molecules or atoms.
And when you know what you are looking for, you build a library of your detector with known components, and then you go into the field to look for specific components that are already in your library.
And you use it for?
explosives and drugs and the other threats, even if we cannot smell it with our own nose. You can measure it with the instrument.
So, for instance, if you want to find this, because this molecule could tell you
this molecule is present.
Yeah, then it is an explosive or not.
Luckily, we already know that explosives are mixtures of different molecules because of the manufacturing process, because of the storage, or because of transport. So then you see a mixture of different peaks, and each peak tells the story.
Okay, so all this possibility in variables makes it so difficult.
Yes, here we also see the influence from other peaks from the area where the sample was taken.
Okay, I think we should look at the box again. Okay. Yeah?
Yes.
Yeah. Yes.
Yeah.
Yep.
Yes.
That's for the next...
For later. Some more cards. Vapor detection misunderstandings. So we already have dogs for explosion detections, don't we? So why do we need this kind of technology if you have dogs?
Unfortunately, we cannot control them. So we never know, are they willing to play? Are they willing to please the handler?
Yeah. And they cannot work 24 hours. They need to be trained. The training needs to be maintained. It's a versatile solution, but it's also a very costly solution.
Yeah. This only works when there's no wind.
Environmental circumstances like wind, like temperature, moisture, it does matter a lot. But it does not mean that you cannot do anything. But you just have to take it into account when using technology, that it's right for that one, for that situation.
This technology works anywhere, in any location, at all times.
That's certainly not true.
No?
No. The most important is how sensitive is the technology and how good is your sampling. And when we talk about vapor detection, the temperature is extremely important, because if the temperature is higher, you get more vapors.
Yeah.
There are temperatures where you almost nothing can be found. Check.
Contamination alert.
I know everything about this.
Yeah, you know. Tell me, Marta.
Working with explosives, it's impossible not to leave the traces. So actually we hope that terrorists or perpetrators or criminals, when they prepare something bad, they do not know how many traces they leave. And we are actually looking for those traces. And that's why you have to be certain that you do not leave traces on your own. That the only traces that you...
So you wear suits and...
We wear suits.
Yeah. Another one. Does a sensor really need to be a quadrillion times stronger than the human nose? That's a one with 15 zeros.
Well, it's also a combination of sampling and the detector. When you talk about a sensor, it's not just a sensor. So to give an example, you know, the state of Washington is full of trees. What we want to accomplish is to find one red needle in the whole state of Washington. And then you come into that kind of sensitivity and order of magnitude. Yeah. But it's the complete system, so it's not just the detector, it's also of getting that one red needle, that pre-concentrated vapor into your analyzer.
Okay. New icon, let's take a look at this one. It's like a light bulb, the one with the little triangle. Oh, here.
Yep.
This one, yeah, over here. Another clue for later. Temperature, volatility, wind, a trailer truck, small amount, time, and some kind of square with favorable, unfavorable, low and high. What is this and how does it work?
Well, what you see here is a representation of the field that we're working. This is the easy part. There's already equipment capable of finding explosives or other threats. And then you have the other two quadrants here and here, where it's already a bit more difficult. For instance, if you have a small amount, it's much more difficult to find. You have a much lower source strength. If you have a high amount of threat, well, it's likely that there will be more evaporation and the strength of the source will be much higher.
Yeah. But even a high volatility object can be tightly packed. So this is actually...
So when it's in a box and it's wrapped in plastic, then it's almost impossible to find. Mm-hmm. Yeah.
with temperature, the amount of vapor you have accessible in the air is higher. So we put the temperature on a favorable, and there's a wind. We were talking about the dilution of our object, so it would work unfavorable.
And then we still have time.
This is the factor we can play with. When you have 2 hours and you want to find a thread in a track, you could do this because you can take actually the whole track. But if there is a terrorist walking around somewhere and there are people involved, you would like to have your solution in seconds.
Yeah.
Time is a very important factor.
So in this truck, it's full of cargo and has an explosive hidden.
First of all, depends where the thread is hidden. If it's hidden here on the back and you are going to sample from this part of the door, then the distance to your thread is higher, so it's more difficult to find anything. If the truck is in Finland during the winter, the chance for finding explosive is much smaller if you have the same truck in Port of Valencia in Spain during the summer.
Yeah. So when it's in the back and it's in Spain and it's really hot, it's in this quadrant, it's really easy. But your research is more about when it's over here, I guess.
Yes. So actually, we are trying to push the technology from that quadrant so that we can also measure in this quadrant, where you have a low source strength under difficult circumstances. So a lot of research is try to get the technology to work in this quadrant. And that requires a completely new concept of thinking about vapors and how to detect them.
So this is a lot about explosive, but you can also use the same technology for narcotics. Can you use it in that way too?
Everything what you imagine have a smell. You can use the vapor technology to checking if somebody is smuggling drugs.
Inside the body.
Inside the body.
Is that something you do by yourself on this department over here, or?
No, because that's very complex, and that's the nice thing about TNO then, that we work closely with our colleagues at Healthy Living, the unit Healthy Living, because they know a lot about metabolism and how products behave inside the body.
Impressive. There was another icon, clock. Take a look.
This one?
Yep. Yeah. Okay. Over there. 2040. Vapor detection technology. What will it look like in 10, 15 years?
Well, I think in 10, 15 years we have progressed a lot to the difficult quadrant. So we will be able to find explosives, narcotics in very difficult circumstances. What we talked about now is more the traditional sampling of air, but we also work on other techniques which are optical techniques. So then we can go much further away, even from satellites, where you can find certain vapors that indicate illegal activities from space.
Really? That's impressive. And when you 50 years further on from now?
I hope that vapor detection will be more recognizable, that people will believe that vapor detection can make a difference when it's properly used. That the perpetrators or criminals see that this technique is working, so they are stopped doing bad things and we do not have to look for them anymore.
A safer world.
Safer world, of course.
Thank you very much. I learned a lot today. If you have more questions, want to know more, or have your own ideas about vapor detection technology, contact TNO. And see you on the next TNO Unboxed.